When we look at an actual mystery gas in space, is it probably made out of just one element? No, right? Most things are made out of multiple elements mixed together. So when we take the spectrum of a mystery object out there, are we probably going to get the spectrums of each element spread apart? Are they probably going to be spread apart? No. Most objects, when you look at them, they're going to have all of the elements' patterns mixed together. And so if something is made out of 100 different elements, then you're going to get 100 different patterns all mixed together. And is that going to be easy to tell what that object's made out of? Yes or no? If you have a bunch of patterns mixed together, would that be easy to figure out? Yes or no? No, that's right. That's right. It's very hard. So sometimes there are scientists who actually, there are astronomers who actually spend most of their time trying to figure these things out. And we can use computers to help us. Computers are trained to find, like a computer really knows this pattern really well, even if it's mixed in a whole bunch of other patterns. It might be able to find this pattern mixed in with a bunch of other patterns. Let me give you one good example right here. Check this out. This is the spectrum of the sun. This is the spectrum of the sun. And actually, this spectrum was taken in such high resolution that they had to chop it up into a whole bunch of different little sections and stack it up on here to get it on the page. Really, it should be just one thing. Now, here's my question here. This one right here, is this a continuous spectrum, an absorption spectrum, or an emission spectrum? Which one are we looking at? Let's take a couple of guesses on that. Continuous, absorption, or emission? That's an absorption spectrum. And again, we can tell because it's got most of the colors, but a few are missing. Now, why does the sun have an absorption spectrum? It's because the core of the sun is pretty close to being a perfect light, but that light on the way out of the sun has to go through the outer layers of the sun. It has to come out of the surface of the sun. So that's kind of like the surface of the sun is a mystery gas blocking our view of that perfect light. So if we were to analyze this, what would we be able to figure out about the surface of the sun? What would analyzing this spectrum tell us about the surface of the sun? What would that tell us about the surface of the sun? What would we learn about the surface of the sun from this? Think we can figure it out? Exactly. What gases it's made out of. We can figure out exactly which substances the sun is made out of. And that's really good because we can't go touch the sun. It's way too hot. We can't go collect some of the sun. This is the only way that we know what the sun is made out of. Okay? So yeah, it's really hard to do because they're all mixed together. Final metaphor of the day. Trying to figure out what the surface of the sun is like trying to solve a murder, okay? It's like trying to solve a murder. Let's say there was a murder in this room, okay? Let's say there was a murder in this room right now. And we have the dude on tape murdering the guy, but he was smart. He covered his face, so we can't see who it is. We can't see who the murderer is, but we see in that videotape of the murder happening. Here's the murder happening. Bop, 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 bop. During that murder, on the way out of the room, here's the murderer going out of the room. On the way out of the room, The murderer touches the doorknob, opens the doorknob, and then leaves. If we want to figure out who that murderer is, what are we going to do? What are we going to do to identify this murderer? What's a good thing to do? Fingerprints, right? You're going to go to that. I'm not the murderer now. I'm the policeman. I'm going to go to this doorknob here, and I'm going to test it for fingerprints, because every person has a certain fingerprint that identifies them, right? But what problem am I going to have when I dust this doorknob for fingerprints? What problem is going to show up when I dust this doorknob for fingerprints? Why is this going to be hard to identify the perp? There's a ton of fingerprints on that doorknob, right? There's a ton of fingerprints on that doorknob. And you know you got the murderer's fingerprint in there somewhere, but because there's so many fingerprints mixed together and possibly overlapping and smearing each other, it's going to be really difficult to identify that one guy's fingerprint, right? That's the same thing when you're trying to figure out what the sun is, right? Every element has its own fingerprint. Like this is the fingerprint of hydrogen. And that fingerprint right there is in there. Let's say hydrogen murdered someone, okay? And you have to prove it murdered someone on the sun. So in here, you have to find hydrogen's pattern. That's why it's so difficult, right? So every element, there's hundreds of elements and molecules in here, each contributing their own fingerprint. And you have to separate them all apart to figure out what the sun is made out of. And that's the same for every atmosphere of a planet out there, and every other star, and galaxies, and all that kind of stuff. So yeah, it's difficult, right? It's difficult. And actually, I do want to mention one last thing, because somebody was mentioning it. When we were first trying to figure out what the sun was made out of, they identified hydrogen, they identified other elements, and they figured out what it all was. But there was one pattern in the sun's spectrum that we had never seen before. And so they had a new element. One element on the periodic table was discovered because it was a mystery pattern in the sun. And we didn't know what that element was, so they named it after the sun. Does anybody know what element that is? The element that's named after the sun? Here's a hint. Remember, the sun, when we were talking about the history of astronomy, we said that the system with the sun in the middle is called heliocentric, because helio means sun. Does anybody know what element was named after the sun? Helium. We discovered helium as a mystery pattern in the sun's spectrum before we had ever discovered it on the Earth. So that's why helium is called helium, because the sun has a lot of helium in it. And then later, when we found helium under the ground, we took a spectrum of it. They were like, oh, here's a new substance. Let's take a spectrum of it. And when they took the spectrum of that mystery gas that was under the ground on the Earth, it had the exact same pattern as the mystery gas in the sun. And so we were like, oh man, that stuff, that's helium. So that stuff that you breathe in from a balloon and go, and then talk real loud, talk like this, that is a big part of the sun. And we discovered it in the sun first. Okay,